Hey guys, welcome back to the channel. So this is the next service upgrade. I gave a preview on the first one when I was doing the ground rods, so part one. This is part two. This is in Brielle, New Jersey, and the customer of this house, who is the trust of this house, is a fan of my YouTube page. He found me, decided to give me a call and see if I could price out this 200 amp service upgrade for him. This service that you see here now, that's the old 100 amp service, which is only about 4 or 5 months old, maybe a little bit longer. I called the building department just to make sure that this thing passed inspection. I don't know why they didn't change out the panel, but I'm not going to go into great detail because I don't think it's necessary. I'm not exactly sure of all the circumstances, but this 14 kilowatt standby generator was put in, and they updated obviously the service on the outside here, but didn't bother to change the panel. Well, when this guy came into the trust of the property, decided he wanted a 200 amp service here, and he asked for a square DQO panel, which is of course what we gave him. I think he's very happy with the work. This work is still pending the final inspection, and I'm probably going to go back once he calls me and all the other work is wrapped up kind of at the end there, because I still need to identify all of the circuits inside the panel as required. So I've never updated a service that was this recently done. Obviously everything here is brand new, including this transfer switch. This is a 100 amp non-service rated transfer switch, and that was one of the issues. So when you have a non-rated service disconnect for the transfer switch, okay, or the automatic transfer switch that's service rated is what we should say. When I take this out, what I need to do is I want to put in a whole house transfer switch that's service rated. So what that means is I won't need to put in that emergency disconnect you see there now in that 100 amp panel, because the automatic transfer switch will be service rated, so that will be the emergency disconnect and the automatic transfer switch as well. And of course, when you do that and you're using it as the main disconnect, it has to be service rated. That's in the code, and I'll put that code section up here on the screen momentarily. So I'm not totally 100% familiar with all of the wiring that goes on with the Kohler standby generators. Obviously I had to buy the 200 amp transfer switch for this job, and I read the paperwork, and it wasn't really that complicated. It's not that much different than Generac, but it is different as far as load shedding. Inside this transfer switch here is a module, a current transformer, which acts as the load shedding part of the load shedding process of a Kohler generator. So that's a little bit different than what we do with Generac. I got more training and more experience in Generac, but I was able to handle this, and this was not a problem. So the owner asked me to carefully take down that transfer switch because he's probably going to try to sell it on the marketplace. It is only a couple months old. Of course, something new like that transfer switch probably somewhere around $700 or $800. So this will be a used one. It's got a couple of knockouts, obviously, in the back of the panel, so I'm not sure as far as what their resale value is going to be like. I know if I was looking for something, I know it would work, but I'd have those holes in the back of the panel, and if that didn't match my current setup that I was putting that transfer switch in, then that would be a problem. I have to put a KO seal in there. Then of course, if it's outside, we want to make sure that water doesn't get in it. So on the inside here, this is an old square D panel. I want to say this was probably put in the 1970s, if I had to guess. It was still in pretty decent condition, as most square D QO panels are, no matter the age. Most of them are in pretty good condition, and this was no different. This was put in very well as far as I could see. All the circuits weren't labeled appropriately, and there was a few twins in here and some multi-wire branch circuits on single pole circuit breakers, so we had to update that when we put the new panel in. There was a total of over 20 circuits in here. This was pretty full, and it took a little while to get this one out of there. But here, obviously, I'm just taking out all the conductors. I had a few, like 50 and 60 amp circuits in here. It was kind of strange that we couldn't find any of them in the house. One went to an oven, and some of the other stuff, I wasn't exactly sure where it went to. But I guess when we identify all the circuit breakers later on, we'll find out exactly where they went to. This house was built, I believe, in the late 1950s. This is Brielle, New Jersey. That's the southernmost part of Monmouth County, right before the Manasquan River. And it was real nice to get a call from a YouTube subscriber or a viewer to do a job like this that was so close to home. As you know, I live in Point Pleasant, New Jersey, and I travel up and down the Parkway most days to Westfield, Cranford, and Clark areas. And then, of course, on Tuesdays and Thursdays in the evening, I teach a group of apprentices at the NJ-IEC Education and Training Center in Somerset, New Jersey. Now, I know I've spoken about this before, but if you are a young apprentice or even someone a little older than young, maybe you're in your 30s and you're looking to become an electrician, you have to pass this Department of Labor approved apprenticeship program in order to become a journeyman before you can sit in to get your license in New Jersey. Those are the laws. Hey guys, so I haven't been able to narrate anything I've done so far because I've been busy obviously taking down the service on the outside, and I just did a 1-hour Zoom call with the IEC board for the Education and Training Center. So now I get a little bit more into the video. As you can see, we've relocated the telephone equipment. When they drilled this, they drilled right through the stud right here. So my main concern here was, do I have 14.5 inches for the new panel between stud bays here? So I can see the stud bays open here. So if you measure 14.5 over, it's right there. And this is where they drilled through. So my biggest concern here now is that the panel cover is going to fit on there without moving this over. If I have to notch away some of the sheetrock, I will. But for the time being, we're going to leave the telephone equipment right where it is and hope it doesn't affect us going forward. So now I'm out of the way. My next step here is to remove the branch circuits from the panel. There's a piece of conduit that's going down with some Romex sleeved in it. I'm not sure if it's being used or not, but I got to hook it back up. And then we'll be able to take this enclosure out. I want to get these branch circuits out of there and get the enclosure out of there and then take a break for lunch. It was very odd to find this piece of galvanized conduit with Romex sleeve because it goes right through the garage floor and into a space I'm not sure where it goes to. And I had to hook it up because it was hooked up previously, so I guess when I identify the circuit breakers, I'll find out exactly where it goes to. Most of the circuits here, I think all the circuits here, were non-metallic sheath cable. This is the early version from the late 1950s. And there was a lot of circuits here to remove. And even the connectors that connected it to the enclosure I'd never seen before. So once I pop those out, I'm able to move the panel out of the way. Looks like model, use square D type QO breakers. Catalog number QON-20M Series 1, 100 amp main lugs, 240 volt alternating current, using box QOB30, suitable for use as service equipment, the Square D Company. Underwriter's Laboratory inspected panel base number. This is it. I don't remember ever seeing an old main breaker like this one. But it's working very well. Sometimes you turn these off, you can't turn them back on. But Square D is definitely some high quality stuff. All right, guys, it's after lunch now. Here's the transfer switch that we're going to be putting in right here. It's a cool Kohler 200 amp service rated entrance switch. And it's basically going to go back to where the other transfer switch was. This enclosure is a little bit larger. And so I need to do two things. I need to make sure that what I want to do is I want to come out of the bottom of the transfer switch with the load going to my electrical panel on the inside. But then I also need to make sure that the generator set that comes through the wall is going to come into the back of the enclosure, lines up with that. And then of course the last conduit that comes out of that transfer switch is the line side from the meter. So what I'm going to do is I'm going to take this out of the packaging right now and just do a dry fit and see if that's going to work. I can hole saw the hole for the load side conductors going to the panel, and I can install my panel. All right, so I just put the panel cover in here and I measured it to 78 inches right here. And we're just below that, so we're good there. I drew with a Sharpie here the hole that I want to come through from the load side of the transfer switch into the panel. So now I'm going to drill a pilot hole right in the middle here, and then go outside and hole saw from the outside in so I don't damage the cedar shakes. This is just a pilot hole. Point of reference for when I get to the outside. It is just a little bit bigger than the connector. I went over this male adapter on the top of my meter pan. It fits over. So this hole saw, and I'm not exactly sure the size, probably says it on here, I just don't see it. But it's just a little bit bigger than that male adapter. So there's a little bit of play in there. So obviously you can see here, this is where the pilot hole came through. So I'm in the middle of this shake, which is good. Much easier drilling in the middle of the shake than it's going to be in between the two laps right here. Maybe even reverse to start this. I don't want to damage the cedar shake. Came out nice. A front-facing fitting that's going to fit in here just like this. So there'll be a short, well, actually it's going to sit like this. So obviously I got the pilot hole drilled and the hole saw drilled, and so I'm coming into the bottom of my new panel enclosure here, which is very nice because when you're running your conductors, your feeders from the main disconnect here, which is going to be the automatic transfer switch, it goes right into the bottom of the panel, and then those feeders go right up into the bottom of the lugs. Of course, those lugs you can put on the top or put on the bottom. I decided to put on the bottom to leave more gutter space for my branch circuits. When I go to land my circuit breakers, everything's nice and neat and orderly. So this here is a 200 amp automatic transfer switch by Kohler generator products, and mounting this, I wasn't exactly sure where I was going to go, but I had to figure, you can see those two holes that are back there, that's where the feeders for the generator go through the garage and then down into the crawl space, and the generator's over there at the far right of your screen up by the top. So just imagine this property in the garage here, it goes down into a crawl space and then comes back out to the generator. So I wasn't planning on moving those anywhere, and so I had to figure out where the knockout was going to be on this enclosure, where it's at a readily accessible height for the disconnect, and then of course where the conduit's going to leave that transfer switch going into the load, where the circuit breaker panel is on the inside, and then of course also a conduit for the meter. So I had a good idea what I wanted to do, and it turned out just right. This was a piece of 1¼ PVC that comes into the back of the automatic transfer switch there. And then of course there was a communication cable that comes in right beside it, and we wound up putting a rubber grommet to prevent the sharp edges of the enclosure from ripping into that sheathing on the communications cable. And like I said previously, the Kohler generator is a little bit different than the Generac. I don't know, people say, oh, I think they're better than Generac, but Generac has like 80% of the residential market locked up. So you tell me. I know Generac has their problems, and the more you sell, the more magnified they are. But in my opinion, Generac is a great product, and I think this Kohler is really good too, I got to be honest. I know more about Generac, and that's how I was trained, and I would definitely endorse Generac for your standby generator needs. But I would not turn you away from a Kohler. I'm just not very familiar with their installation procedures. Of course, you can always get training in that. To be honest with you, me as a one-man team doing the generators, it's not the easiest job in the world, although I don't like to say no to them, but sometimes I have to. That's what I need. I just need a... Alright, so obviously you see I'm frustrated a little bit here doing this. I want to make sure everything's just right. You got to have this one coming from the generator. This is that communication cable. We'll get a rubber grommet in there of some sort. Obviously this, I want this to be level, so when water falls on it, it doesn't get in here and make its way in. Keeping water out of the enclosures is obviously a big responsibility for the electrical contractor. We want to work to prevent water from going into anywhere. And so as long as this conduit entry point is below the live parts, the Myers hub is not necessary. So I just use a regular male adapter here. And I believe that suffice for this installation. Should the conduit enter above those live parts, well, then you'd need to add something that's known as a Myers hub. That it's a little more waterproof. It actually has a gasket on the lock nut itself to deter the water from coming out. And then, of course, there's threaded hub at the top, which is similar to what we use on the top of our meters. It's called a Myers hub. Definitely required if it's above those live parts, but if you're beneath it, it's not required. So we don't install it there because we don't need to. And I believe this installation will be totally watertight after I'm done here. But what I'm doing here is I'm just extending that piece from the house side to the LB so that it sits off the house evenly. And you'll see here I pull it back out because what I should do is put my connector side into the transfer switch first. We'll nudge the piece of conduit into the fitting and then finally into the coupling on the inside by the house there. And of course we want to make sure it's level. See, we got the duct seal wedged in there behind the washer holding it in place. And when I go to put it in here and tighten it down, you'll see it wedge in. Now that duct seal is pressed in there, it ain't going nowhere. Just take that excess off, make it look nice. Same here and here. And I can do my last screw and washer with the duct seal, with the remaining duct seal that I just peeled off in this fourth screw here at the bottom left. Keep in mind too, when you're using the duct seal on the outside and the exterior, it must be rated for exterior use. And so right on the packaging when you open it up, it should say indoor, outdoor usage on the package. I know in New Jersey here, not all electrical inspectors ask for that, but some have in the past, and I'm able to produce a receipt or the package that I have on the truck, and I show it to them that it's this brand, so it's good for the outside. Otherwise, I don't know how they would check it, but I think you can kind of tell by the texture of it. I think the indoor use only stuff is a little shinier, if I'm wrong. I'm not going to mention any brands here, but I do use Arlington duct seal from my supplier, Good Friend Electric, here in Brick, New Jersey. So what am I doing here? So I'm still attaching screws, I believe. Oh, I'm getting ready to mount the 200 amp meter, and so it's not a meter main combination because the transfer switch is an automatic transfer switch 200 amp, and it's a service rated transfer switch. So that's going to act as not only the transfer switch for the generator and utility transfer, but it's also going to act as the emergency disconnect that's required by NEC Article 230 TAC 85, which is interesting because I've seen on other YouTube videos that I follow somebody who I believe sits on a code making panel claiming that Article 230 TAC 85 is going to go away for the 2026 National Electric Code. So it's not really going to go away, but what it's going to do, they're going to delete that section. They're going to make 230 TAC 70, which deals with main disconnects, be required to be on the exterior of the house. So it's kind of doing away with one and adding to another existing code. Just for, I don't know, to make it complicated and uneasy for other electricians to understand. Why they do that, I don't know, but they sit on the code panels and they discuss these rules and they make these changes, and you know, I guess they have the general public in mind for safety, but why add it one cycle and then 2 cycles later take it out? It just kind of boggles the mind, but we don't live in a perfect world now, do we? All right, so here, this is the piece of PVC that I bent the first thing in the morning, just so I can get that right angle at the top of that soffit right there. It's very close to not being 10 feet high for the bottom of my drip loop. I think it's about 13 feet or maybe 12 feet to the top of that pitch right there. But as you can see, the existing service drop was there from before, and I did measure the drip loop from the previous installation, and it was not 10 feet. So I made sure I went up a few more inches to the exact top, as high as I could go, and then my drip loop was absolutely higher than 10 feet from the ground, which is a National Electric Code section that must be adhered to for service upgrades. And so here I'm just strapping up the piece of PVC, the 2-inch PVC, and right at the end here I'll measure before putting up my last piece with the service head, I'm sorry, with the weather head up at the top here. This was a long day, and this is actually the first time I've ever done this on a service where I worked on the service all day, and I usually turn the power back on that same day. But this job took a little bit longer than I had anticipated with that transfer switch. You might not notice it in the video here, but it did. It took a lot longer, and I wound up not leaving this house till about 7:30 at night the first day. But being that nobody was living there, it was not an issue to leave the power off until the next morning when I came back, and then the panel, the service, electric service was restored by around noon the following morning. But for today, the grounding was done the first day. All this other work was done the second day. And then finally on the third day, I'm going to connect all the branch circuits, which you'll see momentarily here. If you're enjoying this video, do me a favor, hit that like button. Thank you guys very much. There were quite a few pieces of chipped metal inside this enclosure from some of the holes I had to drill for the conduit entries here. And I don't like to leave those charred pieces in there if I can help it. The previous transfer switch that was there, it was just filled with charred metal, not charred metal, but little broken pieces of metal from the knockouts that take place in the transfer switch during construction. Not a good idea to leave those parts in there like that, as far as I'm concerned. And I think the code does address that someplace. I'd have to find that, but it would probably fall under workmanship, Article 110, Tac 12. Execute work in a workmanlike manner, but of course they don't define what a workmanlike manner is. So that's up to us and the AHJ, or the electrical inspector here in New Jersey, since we follow the Uniform Construction Code that adopts the National Electrical Code. All right, so here I am wiring the load side of the terminals inside the transfer switch, which goes inside to the panel where all the circuit breakers are. And this took a little bit of time. I did do the research on as far as box fill or conduit fill on this 2-inch PVC, and I am allowed to use 3 pieces of 4/0 aluminum and 1 piece of number 2 aluminum for the equipment grounding conductor. That's just below what is required, or it's just below the maximum fill for this conduit. Using Chapter 9, Table 1, 4, and 5 to figure that out. We go over that at the IEC school in Somerset. And box fill, that's another big chapter that we cover. Obviously, your first year as an apprenticeship. So as far as the size of those conductors, they break them down into decimal points in the back of the NEC in Chapter 9. So you know exactly what type of conductor can fit in what size conduit, so that things are sized appropriately. The most important thing to remember when sizing conduits and using conductor sizes is every electrical conductor makes heat. So anytime you have wiring going through conduits or anywhere, you have to consider the heat factor. And so what the National Electric Code says, anything more than 3 current carrying conductors in a conduit, we have to start derating them, which means there's a column in the ampacity table in 310 Tac 16. Usually we use the 90-degree column depending on the conductor and the insulation type to find out what we need to start deducting from that particular conductor, and of course how many conductors we have in the conduit. It is a great scope of detail involved in learning that. And so I'm not going to get into it here in this video, but just know that if you'd like to learn more about it and you'd like to become an apprentice, maybe a journeyman, and then eventually a licensed electrician, there's links below in this video in the description for the NJ-IEC. So if you're interested, get registered and make sure you send an email to our executive director in Somerset, and she'll be happy to get back to you with more information regarding getting ready for school. School's almost over for this year, and I kind of can't wait because the Tuesdays and Thursdays, every day when I work, I have to leave, stop what I'm doing, and get up to Somerset to teach. So it is a big responsibility to keep doing that, and so I'm anxiously awaiting the end of the school year, which will be, I think, April 8th will be our last night, and we're looking forward to it. All right, so here I'm just using a step bit, and I need to put in what's known as the intersystem bonding connector. And that bonds all of the electrodes on the outside of the house, such as like your cable television, your satellite dish, your data or telephone systems. They're all bonded back to the main disconnect, which was right outside there, as you saw. The panel on the inside here is a main lug only panel, which means it has two hots, a neutral, and an equipment grounding conductor. Here I'm using the Racketeer's staple shark to remove the staples from the framing members here, and some of these cables were a little bit too short to enter the top of the panel, so I had to take out these staples, open up the sheetrock, which the owner had no problem with me doing, so that I could maybe pull a little bit of slack out of the top of the ceiling here so that they would reach inside the enclosure. I was very fortunate. There was only one circuit that needed to be extended, and when I came back the following day here to do that, that's exactly what I got done. So this was a good idea from the start. Alright, so now I took out some of these staples here. None left. Some of these are actually going to fit now into the panel, or are long enough to get into the panel. So the connectors that I'm using are either going to be those white connectors that you used to see in my other videos, or the black button connectors. Both of them are rated for more than one conductor in each connector. I would definitely encourage you to take your time and think out how all these branch circuits are actually going to go into the knockouts here at the top of the panel. Try to keep them in a nice, neat, workmanlike manner. Of course, sheetrock's going to go back over this. I wasn't too concerned about strapping any of the cables there. I probably could have put a piece of 2x4 on the flat between the two stud bays. I didn't. We just went right in there, and the sheetrock's going to go, the patch is going to go right over this. Again, just so you know, the homeowner did tell me to go ahead and open the sheetrock, do what you got to do. We're going to patch all that. And if you see a big bunch of sheetrock missing to the left of the panel, that's because they added a disconnect there for some type of 240 volt load. I'm not sure which because I haven't labeled the panel yet. And they extended it out of the panel and put it to the left of the panel. I'm not exactly sure why they didn't just put it into the main panel. It didn't make any sense, but somebody did it and it's done. What we want to do is we want to consolidate all these different enclosures when you're doing an upgrade so that everything's into one enclosure here. This is a 42 circuit main lug only panel by QO, and I believe there was maybe 32 or 34 circuits here, including the surge protection, which went in here as well. And then we ran one additional circuit here. I don't know if I got any video of it, but we did do a Tesla electric vehicle charger here as well. I don't think I captured that on video though. That might have been the second day when I was there that we did that. So that might not be included in this video. But what I'm going to do is I am going to go back here to do the final inspection. I'll make another video then so you can see the final product and how nice it's going to look, especially the holes that were left on the outside of the house, which I was also told not to worry about. That he would have that fixed. He would just tell me to just do the electrical service how you normally do it, and we'll take care of any damages along the way, which was very nice to hear. Some people don't understand that, and some people don't want to deal with that. So this particular customer of mine kind of understood exactly what I was doing here and what needed to be done, and he gave me plenty of leeway to do what I had to do a nice clean job here. So that explains all of the broken sheetrock everywhere. So if you're looking at that, you're wondering about that, now you have the answer for that. So here I am, and this is these are the branch circuits going in. He did give me, for whatever reason, the homeowner supplied me with arc fault or dual purpose arc fault GFCI QO circuit breakers here for each of the individual circuits, for each of the 120 volt circuits, I should say. So the whole house, except for the double pole circuits, which are normally, you know, appliances, air conditioning, ovens, and that kind of thing. All of those are not arc fault or GFCI protected, but all of the other circuit breakers are. And he supplied all of them for me here. So they are not required here in New Jersey when you're upgrading an existing electrical service. But we did add a couple of new circuits, and those would be required to have the arc fault protection or the GFCI protection, or both, if required by the National Electric Code. So Article 210, TAC 8 shows all the requirements of new circuits for GFCI protection, and Article 210, TAC 12, you can find all the requirements for arc fault protection. The two circuits that I ran through the crawl space, and there's not much video of that either, unfortunately, were to a bathroom, a remodeled bathroom. And so being that these are new circuits to an existing structure, the requirements for arc fault and GFCI were both required. So both of the two new circuits that I ran to the bathroom were arc fault GFCI protected. But like I said, this guy supplied me with all the circuit breakers of arc fault GFCI protection for every circuit in the house. He did have a problem with one of the circuits, and I did kind of warn him that that might happen. If somebody does some extra work inside the house and maybe doesn't know what they're doing, or they cheated, there was no neutral, or there's a ground rubbing up against a neutral someplace, these arc fault GFCI combination breakers will sense that and they'll trip, and then you have a problem. So I did warn him of that. He said that he was going to find out and take care of what the problem was, but I'm not sure. Maybe when I go back there, I might have to repair that. We'll find out for sure. I'm sure Matt is going to comment maybe below in the comment section on the work that I did there. That would be nice. And if not, well, I'm just telling you what happened there for real. I do got to say, being that I've done 3 or 4 of these QO circuit breakers panels in the past couple months here, especially here on the channel, the QO stuff is really, really nice, but it's very expensive. And so not everybody has that, you know, $600, $700, $800 difference to add QO to the upgrade. But if you want it, obviously I'll do it. But you know, my pricing is pretty competitive, I believe, and you get what you pay for. So if you want a higher quality electrical panel, you want the QO, just understand that it's going to cost more than what I normally put in. Obviously I put in the Cutler Hammer BR panels mostly, and I think those are of high quality. That's what I have in my house as well. But if you want something better, we'll get the QO for you. You can either drive a Cadillac, like the QO panel here, or you could drive a Ford Taurus, which would be like the Cutler Hammer BR. The choice is yours. I like the Cutler Hammer BR, but I also like installing these QOs too. The difference with the QO circuit breakers, which makes them better and more expensive equipment, is inside the circuit breaker there's a magnetic field which gets hot, which opens up the latch and trips the circuit breaker should an overload happen. Okay, and so with the design of the QO circuit breakers, there's actually 2 of those magnetic fields inside the circuit breakers rather than 1, which you would find in the Cutler Hammer BR. That's the difference between the QO and everything else, is the design and the magnetic field for overloads and short circuits and, of course, ground faults. They're a little more sensitive to those events. Therefore, they're a higher quality, and, of course, they cost more money. Let me know if you knew that about Square D and whether you have comments about Square D. I have installed Square D home lines previously on the channel. You can go back and look at some of my older videos. Did a few home lines. They're okay. My biggest problem with the QO and the home line equipment is the enclosure holes for the panel screws that hold the panel cover in place. On a surface mount panel like on a flush mount panel like this, those holes never line up. I don't understand that. The other problem I have with QO, and this is minor, is the door, the mechanism, the hinge, not the hinge, but the opener to open up the door to look at the view the circuit breakers. It gets stuck. It gets pinched in there sometimes. It's not the easiest thing to open up. Not that you need to open that up every day. But the other day I was showing a customer where I installed a QO panel, and it was like a difficult time just to open up that door. And so, in my opinion, that design is just flawed, and they never fixed it. And those are minor details, but if you need to open up your panel and you just spent several $1,000s to have this done and you can't open up that panel by yourself, that to me is a problem. All right, so here I am feeding my riser cable, or riser service entrance conductors, up to the weather head here, and I'm ready to what we call bug in. Okay, now this particular neutral was broken in a couple spots, and so once we get the inspection, we'll call JCP&L. We'll have them come back and maybe even draw a new supply over to this weather head. The neutral conductor obviously is pretty important. If you lose that neutral conductor, well then your house no longer has any parallel connections, which provides a standard voltage of 120 volts to ground or to neutral. When you lose that neutral conductor, you'll have what's known as a series circuit, and so everything in your house is connected to series. And if you have multi-wire branch circuits, you could definitely jeopardize equipment that's attached to those multi-wire branch circuits, just because of the laws of series circuits and parallel circuits. So they will have to get back here and make this adjustment. I just figured I'd throw that out there. With JCP&L, you're always going to have what's known as a DR number to get that work done, and that stands for design request. You can call JCP&L and get that. I need to get that anytime I do a service in the JCP&L area. All right, so here the power's back on, and I've checked it. I'm going to check leg to leg, which we call L1 to L2, and then L1 to neutral and L2 to neutral. I'm also going to check for continuity my load connectors before I put this meter in. If you have any kind of short circuit, you go to put this meter in right here, you will get the arc flash of your life, and it's very dangerous. It happened to me one time. I think I spoke of it before. So we just pound the meter in. I like to put the date, the temperature, and the weather. 62 degrees and sunny. That's not required. It's just something I like to do. And sometimes getting this meter cover on, this is a 200 amp meter, can be a pain in the neck. And that's why I'm making sure that that meter's all the way in. Then there's a little locking mechanism here at the bottom. There you go. Once you get it started, I'll come back with my alignment pliers and just tap that home. There, it's completely shut. Now I'm going to take off the cover for the transfer switch and check my voltage here at my automatic transfer switch, emergency disconnect combination switch here. Okay. And this video is just about over. If you like this video, I appreciate it. If you're still here and you watched the whole video, thank you very much. Don't forget to like this video. Leave a comment down below whether you like this video, whether you don't like this video, or if you have a question about the installation. Then, of course, if you want to see more videos like this, hit that subscribe button. I really appreciate subscribers and people coming back and watching these videos over and over. Thank you very much, and I will see you on the next video. Hi, this is Ron from Classic Electric. YouTube thinks that you'll like these two videos on the screen, so go ahead and check them out. Don't forget to leave a comment, like and subscribe, and we'll see you on the next video. Thanks for watching.